Hi, this is Sebastian with another Magic Quartz video. You know, I've been working on this motor controller project for quite some time, actually more than a decade now. And when I came out with the first version of it last year, which is this thing, the Magic Quartz Tech Demo, people were really amazed by its design and features. And you know, this is a DIY project, and people came to me and said, "Hey, this is so cool, but it's so complicated. I don't know where to start." So, first of all, let me tell you, it's not that complicated, and I hope to create another video where I will actually build one of these. Um, but I get the point. You need to source all the parts and wire everything up together to get it working, and this takes quite some efforts. And so, this is something I would love to address in this video because there's another way to get started. And I already mentioned it in my previous video. You can also run the firmware on a standard Arduino development board. And of course, you can also connect all the peripherals to this board and use this to build a motor controller. It's very simple. And it should be a matter of minutes to get it up and running because all we need to do is we need to low pass filter the PWM signal to have a true analog sine wave, which is the AC that we need for the turntable later on. We need to amplify this using a small digital amplifier. And then finally we need to increase the voltage, in my case to 220 volts, using a transformer. And that's it. It's very simple. And this is what we're going to do now. And let's see if it's working or if the magic smoke will escape. Okay, this is the Arduino board that we're going to use. I already flashed the firmware to it. If you don't know how to do it, please have a look at my previous video where I explained this in detail. And we're going to use the LCD keypad shield. When you connect these two boards, you should check that the USB socket does not short out the board on the keypad shield. So if both come into close contact, just add some paper or insulation tape between the two parts. So this resolves the problem. And I'm not going to connect the Arduino to a computer. Instead, I'm going to use this power bank. The reason for this is because we have it fully isolated from ground. I will come back to this later. This gets important when we do some measurements with the oscilloscope. So, but now let's see if it's working. Looking good. Yeah. So, and to be on the safe side, I'm going to reset everything to its original state, and so you can follow me along and see what the settings are that we need. So first we move the cursor below the M and go into the menu, and there we select format memory, yes. So now we have to restart it, and we simply press the reset button here. Now it's restarting again. Okay, and now it asks us to set up the motor. So we keep 50 Hertz in this case, and we set waveform to 2. So this is a full sine wave with software side pop suppression. This is what we want. You can read about this in the manual if you want to. We keep phase shift at 0 because we only have one phase. Yeah. Now, because we have nothing connected, we can press OK here, and we set the voltage factor to 1, which generates the maximum amplitude. So this generates the purest sine signal. Okay, and that's it. So this is now working, and we can use all the features of Magic Quartz. Okay, so now we can actually connect some parts to it. Sorry to interrupt the video, but this is very important. The electronic circuit I'm about to build poses several serious dangers. Please do not try to replicate my experiments unless you really know what you are doing. I recommend that you pause the video and read the text carefully. Now let's continue with the video. Okay, so now we can actually connect some parts to it, and the first thing that we have to do is to connect the low pass filter, and we have to look up the manual where the PWM signal is output. I think it's 44 and 46, but this is easy to look up. Yeah, and I was right. So this is digital port 44 and 46. Okay, now before we continue, let's see if we can see the PWM using an oscilloscope. And I'm going to connect one jumper wire to port 44 and another one to ground. And then we can attach the oscilloscope probe. There's already a signal. We can connect it to the circuit. And let's see if it measures something. Let me focus on the scope. Yeah. So there we can see the PWM. Let's zoom out a bit. So this is hard to understand if you don't know what you're looking for, but basically this is the PWM sine signal. So up, down, up, down, up, down, and it's slowly moving. It's drifting because it's not really triggering. But if we change the speed, you can see we can make it move into one or the other direction. So this indicates that the board here is working just fine, and we will be able to see the true sine wave when we connect the low pass filter to it. And for this, I have to look up the values that we need. There you can see essentially the parts that we need. So this is a 1K resistor and 2 or 3 capacitors. So these are wired in parallel, so it's actually only 2. And let me quickly get the parts and put this thing on a breadboard, and then we should be able to see the analog sine signal. Okay. So, okay, let's unplug this first, probably it's a better idea. So we start with the resistor, which is a 1K resistor. And then we have the 1 microfarad capacitor. I have a different one, so this is actually 2.2 microfarads, but this is perfectly fine. It's just a quick test if this is working. And we have to connect this to ground. And from there on we have another 2 microfarads, which is a decoupling capacitor in this case. So that's it, that's our low pass filter. And let me show the scope. So I first have to connect it. So our output is here on the right, and here is our ground. And if I now power the Arduino board, we should see the sine signal, hopefully. Yay! Boom. Now let's run the auto setup again. And there we have it. A nice, beautiful sine wave. Now we can of course do all various sorts of things. So we can change the frequency, and as you can see, this also changes the signal on the scope. So let me see. Okay, we have DC coupling, that's why it's drifting. Yeah. So maybe Let's restart this again. And then you can see how it's ramping up. Yeah. So this is working. Excellent. So now the next step is to connect the amplifier. I will get a few amplifier boards because there are a few things that I would like to mention before. So at the beginning of the video, I showed you this amplifier board, which is denoted the amplifier type 2 in the tech demo. And well, if there's a number 2, there is also a number 1. And this is this board, which is a really nice design because it has active cooling, and overall it's a very nice board. But the problem with these is that they die easily. I don't know why they die. It's probably because they don't have a reverse current protection. I don't know. And that's the reason why I managed to kill quite a few of these. So these are all dead and have to go into the junk bin, unfortunately. So if you're trying to build the tech demo, or in this case trying to replicate our Arduino experiments, I strongly advise against using these and instead use this amplifier board. You can find about the technical details on the GitHub page of the tech demo. So what's also interesting to mention is that I replaced the original heatsink with another one that is much better. So the original one was only stuck on with some thermal adhesive, and which has not a good coupling. So I replaced it with a heavier heatsink and also attached this one with a thermal glue. Okay, so and of course we need to power this from another voltage source. And because we are trying to generate 220 volts using a 12-volt transformer, so we need double the input voltage, which is then 24 volts. So we need a 24-volt power supply. So, and I'm going to use this cheap lab power supply set to 24 volts. Okay. So let's connect the power. I know, this is extremely messy, and this is nothing that you would have to run at home, so this is just to test if it's working. No, let's hopefully the magic smoke won't escape. That's alright, still the power supply is still turned off. Enable it. Yes, it's drawing some current and it's working, and the LED is lighting up. So now we can connect the low pass filtered signal. We can feed it into the amplifier. Now, as you know, this is a stereo amplifier and we only have one phase that we want to amplify, and that's the reason why I basically I short both inputs so that the left and the right channel get the same signal. And here are a few new jumper wires. Maybe I should turn this off first. Okay. Now we can connect the left and the right channel to the capacitor. And the ground connection over to here. So that's it. Now we should have a amplified signal, and of course we can measure this with the oscilloscope, but you have to be very careful with that because you know there's for each speaker there's a positive and a negative terminal, but the thing is the negative terminal is not connected to common ground, and this means if the whole circuit is grounded, you may blow up the circuit and potentially your oscilloscope if you try to measure to measure the output of the amplifier. In this case, it's not a problem because we are using the power bank, and in other words, the ground of the whole circuit is not connected to earth ground, as is the ground of the oscilloscope. So in theory we could measure it, but to be on the safe side, I'm going to use a battery-powered oscilloscope that we connect to the amplifier. Now the Arduino has switched to standby. We have to wake it up, but first we power on the lab supply, and then we can wake it up again. Yeah, demo version, I know. Hey, and there we have a signal. Now let's press auto. What this looks like. Yeah, and there we have the amplified sine wave coming out of the amplifier. Oh, you can see this is really not that great. Oh dear. What a mess. Okay. And the next step is to connect the transformer. Now we come to the exciting part that could kill me. So the thing is, the transformer has two thin wires. In this case they are black, and this will output the high voltage, and this is something that we do not want to touch under any circumstances. So that's why I'm going to use these Waco plugs, because of course we also need to attach a outlet to this. Okay, now we have to attach the transformer to the amplifier, and there we have to ensure that the wiring is correct. And you can find the wiring in the tech demo GitHub for this or this type of transformer. So this series is has color coded wires, and it's the same for the whole series. So let me quickly look this up. So as it says on the GitHub page, the wiring sequence for R plus, R minus, L plus, L minus, R plus, R minus, L plus, L minus is red, yellow, blue, green. So as you see, I have disconnected the power because we don't want to create any voltage spikes while working on this circuit, of course. Okay, so now let me see if I can find the voltmeter that we also attach to the transformer, and then we can see if it actually generates a voltage. Okay, so this is the voltmeter that we're also attaching to the output of the transformer. Okay, so what's also important to know is that the PCB on the back of the voltmeter is of course live, so we don't want to touch this either. So let's see if we can get it to generate 220 volts. Now let's connect this again. Then we turn the amplifier board off, because we then slowly increase the volume, and this should slowly increase the voltage. But for this we first have to start the Arduino board, of course. Okay, so this is running. Now I will switch on the power supply, and then I enable the amplifier. And we can see the voltmeter flickering. This is good. This is good. Voila, 220 volts. Now we can connect the turntable to it. And for this I'm going to use a Euro extension cord, which has this nice socket. And I chop off one of the half of it. I have already done this, looks like this. This is really great to connect devices to the whole circuit. So let me untangle this. Oh dear, this is really dangerous. Please don't do this at home. This is really messy. This is really messy. Okay. All right, so this is connected to the turntable. Now let's see. If we can hear Ray. Okay, so now I switch on the LED power supply. And let's now power the Arduino board. Ooh. Okay, so it's working. As you can see, this was pretty messy, so please don't try this at home. If you do, please be very careful. You're working with higher voltages here, which can potentially kill you. And also remember to remove everything if you have children or animals, so this is a serious threat. So if you have any questions or remarks, please leave them down below the video, and until then, see you next time. Bye.